Hello and welcome back to another video. Today I'm going to show how to find the circumference of a circle. For this I'm going to use two methods to find the circumference of a circle. The first method is by using the arc length formula, and the second method is good old geometry. Okay, so for the first method, well, I've already talked about this in a separate video on how to find the arc length. That for any function y is equal to f of x, length is equal to integral of square root of 1 plus f prime of x whole square dx from x1 to x2. Okay, so now what is the equation of a circle? Well, the equation is actually written as x square plus y square is equal to r square. Okay, but that's not the form we wanted in. We wanted in y is equal to f of x. So how do we write that? Well, we can just solve for y and we get y is equal to square root of r square minus x square. But there's a difference, because the equation of a circle, and we want a circle. So, well, if we plot the first one, we get a circle like this of radius r. But for the second one, if we plot it, we get this, because a square root is always positive. That's by definition. So basically what we want is we basically get the length of a full circle is equal to 2 times length of f of x, right? Because this is basically half of this graph right over here. Okay, so now we need to find length of f of x, which is equal to integral of, okay, instead of writing this right now, I'll solve for dy by dx. Okay, so we have y is equal to square root of r square minus x square. So dy by dx is equal to minus 2x, the derivative of the inner function, divided by 2 times root r square minus x square. And that's basically minus x over root r square minus x square. Alright, so now we have the dy by dx. So now we can write the function for L of f of x is equal to integral of square root of 1 plus x square by r square minus x square dx. And I can put the limit from minus r to r. Okay, so let's just simplify that. Integral of r divided by root r square minus x square dx from minus r to r. Okay, now let's put a simple substitution to get rid of the square root. X is equal to r sine theta, dx is equal to r cos theta d theta. Okay, and integral of r square cos theta d theta divided by r cos theta from minus, oh wait, no, we have changed the x, so we've changed the variables, so even the limits will change when x is minus r. Well, so sine theta is equal to minus 1, so theta will be equal to, well, oh, 1 second, wait, I'll just write it down over here. minus r is equal to r sine theta. Sine theta is equal to -1, so theta is equal to minus pi by 2, and sine r sine theta is equal to r, so theta will be equal to pi by 2. And then so we get this thing is equal to r d theta from minus pi by 2 to pi by 2, which is equal to pi plus pi by 2 plus pi by 2 into r, which is going to be equal to pi r. And now the original length is equal to 2 times length of f of x, so that will give the length, which is basically the circumference, which is equal to 2 pi r. Alright, that's actually one part where you can use the arc length, where you can use the arc length in another way, which I find pretty cool. So I'll share it. Well, we can, if we draw the graph. Oops. Well, I'll just make do with it. And I suppose I make an angle theta with the horizontal. Then the x coordinate will be r cos theta, and y coordinate will be r sine theta. And in the video where I talked about the arc length, we can write the length as the integral of dx whole square plus dy whole square. So we can see over here that if we take the derivative of both sides with respect to theta, so dx is equal to r sine theta minus d theta, and dy is equal to r cos theta d theta. Okay, so, and suppose we want to find the length of this section over here, which subtends an angle alpha. Okay, so, well, this one will be some theta naught, and this one will be theta naught plus alpha, though corresponding to this. So this x coordinate will be r cos theta naught and r sine theta naught. Okay, this point's coordinates will be r cos theta naught plus alpha and r sine theta naught plus alpha. So if we write the equation, so length is equal to integral of root r square sine square theta plus r square cos square theta. That's after taking the d theta out, so we take d theta common over here, and from the limits theta naught to theta naught plus alpha, that will give the limits. Substitute, if we simplify this, we get r d theta from theta naught to theta naught plus alpha, which if we simplify we get r delta theta, which is equal to r alpha, or I'll just let it be r delta theta, which is basically part of the circle, which is length you want to find. Alright, so in this special question which we're doing over here right now, you'll notice that in the diagram we have taken, we can remove the second part of the circle, the part which is not part of the function, and we'll still get the length without having to include the other part. So we can directly write that the length of the curve, which corresponds to delta theta, is equal to r delta theta. And now, well, let's say you want to find out the length from 0 to 7 pi by 6, suppose, which is not going to be part of the function, which will extend the function. So that's going to be, well, let's say till here. Well, that also, as it turns out, has the same formula as r delta theta, because as long as we take the correct theta, delta theta, well, over here delta theta is equal to 7 pi by 6. Well, so we can first find the length of the delta theta is equal to pi, which, as it turns out, will be r into pi. And then, well, this is correct because this is part of the function. And now let's invert the graph, and let's say, so, well, we can invert the graph because this we're just finding the length, and this is symmetric. So the length of this part right over here from here to theta is the same as the length of this part over here. So we can invert the graph and find from 0 to pi by 6. So that's going to be r theta plus r pi by 6. And these both are, this one is, and these both are going to add up to give r 7 pi by 6. So we can just write the length for any delta theta is equal to r delta theta. And if you take for a full circle, we get 2 pi r. Alright, now for the geometrical method, the second part, which requires only one formula, the cos formula. Let's see, have a triangle right over here. This length sides are a, b, and c. This line is theta. So the formula is basically c square is equal to a square plus b square minus 2ab cos theta. Alright, this is basically the only formula we're going to use. And now this one does not require any graph, so we can draw a normal circle over here. Okay, this is the center. Okay, now let me take any arbitrary sector of the circle, and this one subtends the angle delta theta, and this distance is r, this distance is r, and let's call this length delta L. And now we know that total length is equal to sigma of delta L. Now by using the cos formula, well, we can use the cos formula on the circle over here, because we are assuming that delta theta is equal to d theta and delta L is equal to dl. Alright, so I'll just watch this. Well, at such a small theta, d theta, and small dl, this part of the circle actually looks very close to a triangle, that the extra curve is basically negligible. So how do we use the formula which we have gotten? Well, dl whole square is equal to r square plus r square minus 2r square cos d theta. And now I'm going to use the double angle property, which says that cos 2 alpha is equal to 1 minus 2 sine square alpha. Now over here, instead of alpha, I'm going to put d theta by 2. So we have dl whole square is equal to 2r square 1 minus cos d theta, which is equal to 2r square into 2 sine square d theta by 2, and take the square root of both sides. dl is equal to 2r sine d theta by 2, and cos d theta by 2 is very small, sine of d theta by 2 is equal to d theta by 2. This is the small angle approximation, and cos d theta by 2 is equal to 1 approximately, but at such a small value it really doesn't matter. So dl is equal to 2r into d theta by. Okay, so well, then we get dl is equal to r d theta, which we got from using calculus in the previous method. So if we get L is equal to integral of dl, which is equal to integral of r d theta, which in turn is equal to r delta theta. So for delta theta is equal to 2 pi, length is equal to 2 pi r. And just for additional purposes, I'll also show you for area of a circle, which can be done easily if you know the circumference. Well, let's say you have this circle right over here. This is the center and its radius is capital R. And let's say you take this part over here. This radius is R, and a tiny shell or a tiny disc, or well, a tiny part of the disc. And this part over here has a length dr. Okay, so this part may seem a bit complicated to few of you people. Just try to be with me. Okay, let's take this part over this shape over here, and let's try to find the area of this shape. Okay, so how do we do that? Well, if we make a cut somewhere over here and open it up like a rectangle, we get this rectangle over here, and we already know the width of this rectangle, which is dr, and the length of this rectangle, well, that is just the circumference of this circle, which we have calculated just now, which is 2 pi r. And the area of the circle is basically the sum of the area of all these of all these shapes. Well, we know dA is equal to 2 pi r dr, which is the area of a rectangle. And if you want to find the total area, which is equal to integral of dA, well, that's basically integral of 2 pi r dr from r is equal to 0, the centermost part, to r is equal to r. And that's basically 2 pi integral from 0 to r of r dr. And this thing is r square by 2, 0 to r. And for 0, this value is 0. And for capital R, this value is r square by 2. So if we plug that in, we get area of a circle is equal to pi r square. Alright, that's it. I hope you like this video. Thank you for watching. Don't forget to like, share, and please subscribe to my channel for more math related